Okay, here we are, Geometry Common Core, period 8, and we're doing the distance formula today. So I'm trying a new way of recording. I've never done it like this, but here we go. Find the length of each line segment below, show/explain the process you took to find the length of each line. Well, for AB, 1, 2, 3, 4, 5, 6. AB is 6. When it's horizontal, you can just count the number of boxes, full boxes. Here, CD, 1, 2, 3, 4, 5, 6, 7, 8. CD is 8. EF is different because you can't count diagonally through boxes. But what you can do is you could count the horizontal and the vertical. 1, 2, 3, 4, 5, 6, that's 6. 1, 2, 3, 4, 5, 6, 7, 8, that's 8. And then you could do the Pythagorean theorem. Now, we know it's a 6, 8, 10, which is a multiple of a 3, 4, 5, but we could show work and say 6 squared plus 8 squared is equal to x squared. 36 plus 64 is equal to x squared. 100 is equal to x squared. X is equal to 10. Okay, so we use the Pythagorean theorem for that. There's a formula. Okay, Howie, how did you calculate the length of AB and CD? Can you use the same method to calculate EF? Why not? For AB and CD, I counted boxes. Not for EF because it was not horizontal or vertical. For EF, I used the Pythagorean theorem. For EF, I drew a right triangle. And used the Pythagorean theorem. Now, the distance formula is actually derived from the Pythagorean theorem. So the distance formula is as follows. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I can show you an extra help, or you could just look it up on a video online and you will see it. I'm not going to do that right now for this lesson, but it is not a bad derivation at all. It really is just using the Pythagorean theorem. So now, and you need to memorize that. So now we had slope you had to memorize, midpoint, and now the distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Find the distance between the points below. Leave your answer in simplest radical form. So D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. The square root of -5 minus 0 squared plus -1 minus -2 squared. That's the substitution. You could let the calculator do the inside at that point. -5 minus 0 is -5 squared is 25. -1 minus -2 is plus a +2 is 1. Squared is 1. 25 plus 1 is 26. So D is equal to the square root of 26. Okay, another one over here. The formula is right there, so I'm not going to have to write it here, but normally I'd write it for each question. The square root of -5 minus -6 squared plus 1 minus 4 squared plus a positive 6 is 1, 1 squared is 1, plus negative 3 squared is 9, 1 plus 9 is 10, d equals the square root of 10. Oh, sorry, I went a little too fast for those who are copying it down. Oh, it's a video. You can pause it. You can pause it any time when it is a video. Good point. So, number 3. Triangle ABC has coordinates A, negative 6, 2, B, negative 3, 6, and C, 5, 0. Find the perimeter of the triangle and express your answer in simplest radical form. So, negative 6, 2, that's A. Negative 3, 6, that's B. And 5, 0 is C. Okay, so I'm going to find the distance of all of the above. Right? If we want the perimeter, we need to know the distance of all 3 sides. So first I'm going to do the distance of AB. And the first time, whenever there's a proof of any sort, I'm going to write the formula out at least once. If I use slope, I have to write it at least the first time, midpoint the first time, distance the first time. So distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. The square root of A and B are up here. Negative 3 minus negative 6 squared plus 6 minus 2 squared. Minus a minus 6 is plus a positive 6. 3 squared is 9. Plus 4 squared is 16. That's the square root of 25. And the square root of 25 is 5. So the distance of AB is 5. Now I'm going to find the distance of BC. I don't have to write the formula again because I just wrote it. Square root of 5 minus negative 3 squared plus 0 minus 6 squared. 5 minus negative 3 is 8. 8 squared is 64. Plus negative 6 squared is 36. 64 plus 36 is 100. The square root of 100, I really seem to make big radicals. Square root of 100 is equal to 10. And lastly, we have the distance of AC. AC, 5 minus negative 6 squared plus 0 minus 2 squared square root of 121 plus 4 is the square root of 125. The square root of 125 is really the square root of 25 times 5, which is 5 radical 5. So find the perimeter of the triangle. The perimeter is equal to, I combine like terms, 5 plus 10 is 15, plus 5 radical 5. So that was number 3. Now, just to discuss, there are certain teachers out there that say that you can use the Pythagorean theorem for each one. So if you want, I did it this way, I do this, it's good, it's great, I like it, and I do that way. But you could do, you could make a little right triangle there. I don't like the way it came out. Hold on. I want to make a line. I'm going to make it in red. So if this is 3 and this is 4, and you do the Pythagorean theorem, that's a right angle, this ends up being 5, which is what we got over here anyway. And people can do that using the Pythagorean theorem. They can say 3 squared plus 4 squared is equal to x squared. 25 equals x squared, x equals 5. I'm just showing you another way you can do it. I know some teachers who have done that. But the distance formula is very straightforward. You get good at it as you practice, and you'll be fine. Now, some different types of questions that can be asked are as follows. Find the length of the segment. Well, we've just been doing that the whole time. Let's go to number 2. Let's see what else we have here. And then we have another page after that. Okay. Sorry, we have, so 1 we know how to do. We've done that. Number 2, well, the point 1, 2 lies on a circle. What is the length of the radius of the circle if the center is located at 4, 6? So to find the radius, you're just doing the distance between those 2 points using the distance formula. Line segment AB has endpoints here. Line segment CD has endpoints here. Are these segments congruent? How do you know? If 2 line segments have the same distance, they are congruent. That is how you decide. So the distance of AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's equal to the square root of 5 minus 0 squared plus 6 minus negative 6 squared okay, 5 minus 0 squared is 5 squared is 25. 6 minus negative 6 is plus a positive 6 is 12. 12 squared is 144. 25 plus 144 is 169. So the square root of 169 is equal to 13, okay? The distance of CD is equal to the square root of 4 minus negative 8 squared plus 7 minus 2 squared. 4 minus negative 8 is plus a positive 8 is 12 squared is 144 plus 5 squared is 25. The square root of 169 is 13. AB is congruent to CD because they have the same distance. Okay. AB is congruent to CD because they have the same distance. The point 3, negative 3, 3 lies on a circle. The center is at 10, 6. What is the length of the diameter? Well, the center to a point on the circle, that's the radius. If I want the diameter, I have to find the radius and multiply it by 2. Or take the radius and add it to itself. And then we have 2 more. One bus is 5 miles east and 2 miles north of a bus terminal. One bus is 5 miles east and 2 miles north of the bus terminal. Another bus is 3 miles west and 6 miles south. So basically, 5 miles east and 2 miles north is really the 0.52. 3 miles west and 6 miles south is -3, -6. So how far apart are the buses? You can use the distance formula to find that. Okay, here's a little north, south, east to west. Okay, and that is how you do the distance formula. The distance formula is used to prove that 2 segments are congruent. Or if you wanted to see if a triangle was isosceles, if 2 sides are congruent, then it's isosceles. If 3 sides are congruent, then it's equilateral. It could be used to prove that opposite sides of a parallelogram are congruent. It could be used to, right? So it could be used to prove that diagonals are congruent. So it has lots of uses, well, all with congruence. So anyway, hopefully you now have a better understanding of the distance formula. And you must finish whatever we didn't do on this sheet. And if I put up a homework sheet, you need to do that as well. I can't recall if I have a separate homework sheet. So you will see. And if you do, you'll have to do that as well. Thank you. Have a good day. Bye. I have to